we have like another river, and you have Jake again. Like I was too lazy to come up with another name. So let's say you have your river, and like you have Jake, and he's like in the water again, and this is him. And then yeah, and we're given that like this time it takes Jake 6 hours to travel a certain distance when he's paddling upstream. And when he's paddling downstream, it takes him 3 hours to travel that same distance. Then we want to know how long will it take Jake for him to travel that same distance in still water? So this question is slightly different because we're given the quantities in terms of time. We're giving information in terms of time, and we want to find a time. In the previous problem, we were given stuff in terms of rates and speeds. So we would use the same like idea for this problem. Let's call the current like speed C. Let C be the speed of the current, and let R be like Jake's speed, right? Jake's rate, R. So when Jake is traveling upstream, right, then he's traveling in the opposite direction of the current. So he's going to be traveling this way at a rate of R. So again, as we found in the previous question, his like net speed kind of is going to be R minus C, right? Since he's going to be trying to travel at a speed of R, but the current is going to drag him backwards at a speed of C. So the current is going to push him back. So like the net speed is going to be like R minus C. And we're given that it takes him 6 hours to travel a certain distance. So we would say 6 times R minus C is equal to D, where D is that like certain distance. Now we're given that when Jake is traveling downstream, so in the other direction, when he's traveling this way, he only takes 3 hours to travel that same distance. So as we found in the previous problem, R plus C is the speed when he's traveling with the current, because the current now is like helping him because they're both moving in the same direction. So R plus C is like the total speed. Then we say it takes him 3 hours to travel that same distance. And we want to know if he's in still water, like how long will it take him to cover that same distance? So if he's in still water, then there's going to be no current. So the speed is just going to be R. We don't know the time. That's what we want to find. And we want to know how long will it take him to travel that same distance, D. So we kind of have like these 3 equations, and we want to know what is this time here. And this might seem like unfortunate because we have 3 equations and 4 variables. And usually if you have more variables than equations, then you usually can't solve the problem. But just note that this is actually pretty common with distance equals rate times time problems. It turns out we can still solve this problem. One way you can solve this is we want to find the value of t. So I can say t equals d over r by dividing both sides by r. And from the first 2 equations, like from the first equation, I can divide both sides by d and divide both sides by 6. So I can say r minus c divided by d is equal to 1 over 6. And from this equation, I can say I can divide by d on both sides and divide by 3 on both sides. So I'd have r plus c over d is equal to 1 over 3. So nothing fancy there. And now what we can do is I can add these 2 equations together. And the reason adding these 2 equations together can be helpful is because now I can eliminate, you have a minus c and a plus c. So the c's kind of cancel out. So if you were to add the right side, you have an r, you have another r. So that has a sum of 2r. And the c's kind of cancel out. And the denominator is d. On the right side, you have 1 over 6 plus 1 over 3. That equals 1 over 2. So now we can divide both sides by 2. And this would cancel out. So I'd have r over d is equal to 1 over 4. So I could just take the reciprocal of both sides to find what t is, right? So d over r is going to equal 4 hours, which is our time. And that's our answer.